Now, students, today's class is for 11th and 12th. When I talk about 11th in CBSE, the chapter of alkyl halide is in class 12th, but in ISC, the chapter of alkyl halide is in class 11th. But the issue is common. The issue is common in terms of increasing the carbon. किसी ऑर्गेनिक कंपाउंड में जिसमें फॉर एग्जांपल एक कार्बन हो, इट हैज वन कार्बन, और उससे हमें दो कार्बन तक ले जाना हो, like from methane to ethane, for that matter methyl chloride to ethyl chloride, or chloromethane to chloroethane, methane all to ethane all, methane all to ethane all. So actually it is quite interrelated. So let us talk about some questions. For example, allow me to say that we have to convert methane to methanol, methane to ethane, I'm sorry, or for that matter, methanol to ethanol, or for that matter, methyl chloride to ethyl chloride, or for that matter, methanol to ethanol, or for that matter, methanoic acid to ethanoic acid, CH3COOOH. Now this is a question. Now this question looks difficult, agreed. But if you follow certain mechanism, if you follow certain roadmaps, if you follow certain name reaction, if you follow certain chemical properties, they might well be converted to easier ones. For example, we can even rub this, and we just take arrows and make it a little complicated in terms of this question, methane to ethanol, or you can convert methanol to ethane, or you might as well say, sir, it is methanol to ethanoic acid. So this is quite interrelated. Now the catch is, what is the catch? You have alkyl halide changing to alcohol. So this is the group, this is the group, characteristic group, functional group, or whatever you need to say about that. Now this is an alcohol group. This might as well be aldehyde group. So this is quite interesting. But remember, what are we going to talk about? Increase in carbon by 1. This is the catch. Increase in carbon by 1. For this, I will take up two small little points. One, how to convert methane to methanol to methanol to methanoic acid, or reverse. To and fro. To means in forward direction, fro means backward direction. Let us see. Allow me to write methane converted to methanol, converted to methanol, converted to methanoic acid. So allow me to write the name methane. I am separating in methanol. I am separating all. Methanol. I am separating al, and methanoic. I am separating oic. Join them together. In all al oic. Carbon is one. Remember, one carbon alkane, alcohol with one carbon, aldehyde with one carbon, and carboxylic acid with one carbon. So, ane, all, al, oic. Ane, all, al, oic. Remember, oxy, Cu, 200. Interesting. If methane heated in oxygen with copper 200, it will convert to methanol. If methanol heated to same condition, it will convert to methanol. If methanol converted to heated in copper at 200 degrees centigrade in presence of oxygen, it will convert to OIC. This is called controlled oxidation. What do we call it? We call it controlled oxidation. For example, methane in oxygen with heated copper at 200 degrees centigrade would convert to methanol. A to all. Next, if methanol heated in oxygen at copper 200 degrees centigrade, catalytic oxidation, it changes to methanol with obviously water. You can balance it. If methanol further heated in oxygen at copper, which is heated at 200 degrees centigrade, it might as well end up being a carboxylic acid. So, air, oxygen, copper 200, all, oxygen, copper 200, oxygen, copper 200, OIC. Aim to all to to OIC. So this is the cloud I want you to remember. Aim all OIC, oxygen, copper 200. One more thing. If you heat methane in acidified potassium dichromate, it will end up here. Uncontrolled oxidation. That is uncontrolled oxidation. Acidified potassium dichromate would always lead to formation of oic acid. Controlled oxidation, ane, all, oic, and uncontrolled oxidation, whatever alkane, alcohol, aldehyde you take, they would convert to carboxylic acid. We select a question called methane to ethanol. We select a question called methane to ethanol. Let us see. This is the question, methane to ethanol. Now, there are 5 methods of increasing carbon. 3 come from alkyl halide, 1 come from alcohol, that is 4, and 1 come from aldehyde. So there are how many methods of increasing carbon? 5 methods. 3 comes from alkyl halide, 1 comes from alcohol, and 1 comes from carbonyl group, that is aldehyde group. Let us take them one by one. Methane with chlorine in UV light changes to methyl chloride, which will end up method 1, method 2, method 3. In this, we add 2 more chlorine in UV light to give chloroform. So 3 methods are on alkyl halide. That is why alkyl halide is probably one of the important chapters as far as increase in carbon is concerned. You can see methyl chloride can be converted to ethyl group with 3 methods. In this method, we can take aqueous KOH, which is SN reaction, and this is free radical substitution reaction. Free radical substitution reaction. This changes to methanol, and methanol can be further oxidized in copper at 200 degree to give methanol. So three methods on alkyl halide, 1, 2 and 3, one method on alcohol and one method on aldehyde as I discussed earlier in my class. So we are talking in terms of flowchart. Then if your comments will generate, we will discuss the equations also. But flowchart increases your muscle memory. Now what do we talk about muscle memory? If you read Frederick Forsyth, No Comeback, and there were some movies also made on that book, Frederick Forsyth, No Comeback. There is a concept of muscle memory. There was one criminal who always, he was very fond of machine pistols and all. So even if he was blindfolded, he would shoot the target, this and that. So like you operate the remote, your thumb remembers the buttons. Like you put on the switch on and off, you don't see it, look at the switchboard. Same way, flowchart will increase your muscle memory, your hand will remember. And in case you forget, your hand stops. So try to work on muscle memory, and muscle memory is the best with flowchart. Coming back, this is method number 1, this is method number 2, this is method number 3, this is method number 4, this is method number 5. Now without rubbing them, this flow chart, I will discuss all of them one by one. Number 1, we have to come from 1 carbon to 2 carbon with alcohol. 1 carbon to 2 carbon with alcohol. Here the functional group is saturated hydrocarbon, that is carbon-carbon single bond, and here the functional group is alcoholic group, but with 2 carbon. Alcohol with 2 carbon, saturated with 1 carbon. So in this, first of all, we will do Budd's reaction. To remind you, there are around 54 name reactions. There are so many Budd's fatigue, Kenny, House, Ullmann, Cannizzaro, Wald-Kirchner. There are so many name reactions. We'll have a separate class on name reactions, and I would try to simplify them in terms of their similarity. But that is not the point of issue and contentions as of now. It's just that one of the name reactions, that is Budd's reaction. What is Budd's reaction? Methyl chloride with 2 sodium and another molecule in presence of dry ether. Now this is interesting. Please remember, whenever you take an organometallic reaction, organo means organic and metallic, always put dry ether, otherwise it will explode. So 2 sodium chloride are released and ethane is formed. Now this ethane can be oxidized in copper at 200 degrees centigrade to give ethane oil. Mission accomplished. So Budd's reaction, increase 1 carbon and then you can oxidize it further. The second method is on again alkyl halide, where you will use potassium cyanide, that will increase 1 carbon. That is, let us see, in second method, methyl chloride, it is again SN reaction. Alcoholic potassium cyanide would give CH3C triple bond N with KCl. Now CH3 C triple bond N, when reduced with hydrogen in nickel at 300 degrees centigrade, it will turn to amine. Amine, when made to react with nitrous acid, it will turn to alcohol. Or you can even hydrolyze this, or you can even hydrolyze cyanide with 2 molecules of water in presence of acidic medium to acid, carboxylic acid, and carboxylic acid can be further reduced with 2 hydrogen in presence of nickel at 300 degrees centigrade to alcohol. So either you can convert cyanide to amine and amine to alcohol, or cyanide to acid followed by reduction to alcohol. Now in third method, we convert methyl chloride to further to chloroform, and in chloroform you add 6 mole of silver atom with 1 more mole of chloroform to convert to silver chloride and ethyne. Ethyne, when reduced with hydrogen in presence of nickel at 300 degrees centigrade, it gives ethane. And ethane, when oxidized in presence of heated copper at 200 degrees centigrade, it will give alcohol. This is what we want. So in this case, chloroform made to react 2 mole of chloroform made to react with 6 mole of silver atom to give silver chloride precipitate followed by ethyne, and ethyne can be reduced to ethane, and ethane can be controlled oxidized in controlled condition to give ethanol. Now in the next method, that is fourth method, we are using active hydrogen method. Let us see. In the fourth method, we have CH3OH, hydrogen electropositive, oxygen electronegative. We use a Grignard reagent with 1 mole carbon. Now what is Grignard reagent? He was a Swiss chemist, Victor Grignard. It is always alkyl magnesium halide or aryl magnesium halide. It is an organometallic compound. So in this case, magnesium is electropositive, carbon is electronegative. So this is the product form followed by methyl magnesium methoxybromide and alkane. And alkane can be further oxidized in heated copper to give ethanol, and this is what we require. So this is another reaction in where you use active hydrogen. What do you mean by active hydrogen? Active hydrogen is displaceable hydrogen. Active hydrogen is displaceable hydrogen because oxygen is electronegative and hydrogen is electropositive. So plus electropositive species goes to electronegative in Grignard reagent. So this is the ethane is the product form. And as I told earlier, alkane under controlled oxidation would give alcohol, and alcohol in under controlled condition will give aldehyde, and aldehyde under controlled oxidation would give carboxylic acid. So methane under controlled oxidation at heated copper at 200 degree would give ethanol. Now the fifth method is on carbonyl group. Now in this, halide converted to alcohol, nucleophilic substitution reaction, and alcohol under controlled oxidation, that is heated copper at 200 degrees centigrade changes to methane ol. Methane ol to methane ol, as I gave this capsule in the very beginning of class. Methane, methane ol, methane ol, methane OE. Oxygen, copper 200. That is controlled oxidation. Now, further, this aldehyde group, has active oxygen that is electronegatively charged and carbon is electropositive charged. They react with Grignard reagent, methyl magnesium bromide, which is an organometallic compound. That is Grignard reagent, methyl magnesium bromide. Now, this electronegative species cleaves the bond, and the intermediate compound is ethoxy magnesium halide. Remember, magnesium is electropositive and oxygen is electronegative. Now this further hydrolyzed in acidic medium to cleave the bond. resulting into formation of magnesium hydroxyl halide followed by ethanol. So, to summarize now, increase in carbon can be done by 5 methods. 3 methods are applied through alkyl halide. One method from alcohol, that is active hydrogen method, and one more from aldehyde group. But remember one thing which I did not discuss so far in this capsule is active hydrogen method is not valid beyond 3 carbon. Beyond 3 carbon. This you have to remember. Again, this topic will be discussed when we decrease the carbon in the next capsule. So today's class has been solely attributed to the very fact that how to increase carbon. Methane to methanol, methane to ethane, methanol to ethyl chloride, methanol to ethanoic acid. It can be converted this way to that way. Thank you very much.